iterators functions in a minimized version so that you don't have to write lengthy lines of code, and you can use that STL and you can get access to a container or to an algorithm. So in this video, I'll be teaching you all the STL that is actually required to get started with DSA. So please make sure you watch this video till the end to understand or to learn C++ STL in depth. So without wasting any time, let's get started. So let's understand the skeleton of a C++ code. So you can see this is the entire skeleton of a code, and the first line is hash include bits slash stdc++.h. Generically, this is nothing but a library, and you would have learned about something like math.h. So in order to include all the algorithms in math library, you have to hash include math.h. Similarly, in order to include all the libraries in string, you have to give string.h. Similarly, if you're wanting to add anything, you have to actually write hash include the library.h name for sure. Now, imagine you're writing an algorithm or a program where you require a bunch of libraries, so you cannot actually waste a lot of time in including all the libraries individually. So what C++ tells us, okay, hey listen, I have all the libraries inside this stdc++.h, so just include this one and all the libraries are automatically included and I don't need to individually add them. Now this is the int main where you actually write the entire lines of code. Now what is this actually for? Using namespace std. Now imagine, just for a case, imagine I write scene of a and a is an integer. So this works, but if you just omit this line, this will actually give error. Now if you don't add this line, you actually have to write std double colon scene of a or std double colon c out of a. This basically takes an input into a. This basically prints the a into the screen. So if you don't write using namespace std, this you have to write every time. So that's a again hectic process. So that is the reason what we do is we write using namespace std and we omit this. But if you want to know about more in depth, you can definitely read a lot of articles. I'll be leaving a link of an article in the description below. You can check that out. So before moving to the STL part, let's understand functions. So there are a couple of functions. One is the void. So if you write void and probably print, and over here you give cout, let's say my name Raj, and I call the print function. So what happens is this print function calls and this will output Raj in the screen. Now this is a void function. What does a void function means? It will not return you anything. Okay, so that is one kind of function, and the other kind of function is a return type function. Assume I write int of sum a, int of b, and I say can you please return a plus b, and over here I say int s equal to sum, can you just do a sum of 1 and b. So what happens is it calls this function, passes 1 into a, passes 5 into b, and returns a plus b. Yes, and it returns a plus b. So you get a plus b, that is basically 1 plus 5, 6 into the s. And now if you do a cout of s, what happens is this actually prints 6 into the screen. You need to understand this. Now this is a return type function, right? Now this can be a double, this can be anything. Like you can use any data type as you wish to. So these are the basic stuffs about the C++ skeleton of a code. Okay. So before moving to the next part of the video, I'd love to thank the sponsor of this video, which is Coding Ninjas. Coding Ninjas is India's leading tech platform. अगर आपको DSA का कोर्स चाहिए, कंप्यूटर प्रोग्रामिंग का चाहिए, मशीन लर्निंग का चाहिए, कोडिंग as well as 1 year 20 containers. It can be vector, it can be queue, set, map, and a lot of other things. And during the course of learning containers, I'll be also teaching you what are iterators. So these couple of things we'll be learning at first. After that, I'll be talking about different algorithms and different functions that do exist in C++ STL. So before moving on to containers, you have to actually learn about pairs. Now what is pairs? Pairs is a part of utility library. Okay, now imagine I say that I want to store a couple of integers. Like I want to store 1 and I want to store 3. So the only way that you can do is you can store it in a pair. Now how is pair defined? You define the pair stuff, and then you say the first stuff that you want to store is of integer data type. The second stuff that you want to store is of integer data type. Then you enclose them into curly braces. So what happens is this actually stores everything into a variable p. So this variable p is now having 1 comma 3. That is the meaning of this particular line. So that's how you define. Now in place of this int, you can also have something like double, string, character. The data type can be anything. Okay, now if p is storing something like 1 comma 3, now if I'm accessing p, it's actually a pair. What if I want to access this 1? what if I want to access this 3? So it's very simple. What you say is you just write p dot first, and that will go and access this particular 1. And if you write p dot second, that will go and access this particular 3. So that is as simple as it can get. So if you're printing p dot first, 1 gets printed. If you're printing p dot second, 3 gets printed. I hope this is clear. Now imagine you're wanting to store. So as of now, you know that if you declare an integer data type or a string data type or a character data type, you can always store a single variable. Like if I want to store int a equal to 2, that's fine. And I also know if I want to store 2 variables, I can use something like pair. But what if the question comes up and they say that when I store 3 variables, 4 variables, 5 variables, can you do it? Yes, we can do it. We can use the nested property of pair. Yes, we can use the nested property of pair. Now imagine I say you that you're going to store 1, 3, 4. So what you'll say is, okay, I have one pair and I know this pair can store 2 guys. So this is the first guy and this is the second guy in a pair. So what I'll say is the second guy can be of a pair data type. Thereby the second guy stores 2 guys in itself. That is how you can do it if you're wanting to store 3 variables. Got it? Like pair of integer. Then in the second guy you say that I'm going to store a pair in itself. So basically 1 comma and the second guy is a pair. So again a curly brace and 3 comma 4. So that's how you can also store 3. And eventually if they're asking you to store 4 variables, you can go nested, 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 that you can improvise. Okay, so that's how you actually store more than 2 variables in a pair. But now if you want to access this one, now if you remember well enough, I told you pair contains 2 guys, right? And this guy was called first. If you remember well enough, this guy was called first and this guy was called second, correct? Now but this second guy now stores 2 guys. So can I say this guy is nothing but first you get second, then seconds first. So seconds first is what this particular guy is. And what is this guy? This is nothing but the second dot second. So this is second dot second. As simple as that. So this is how you can easily access. So if I ask you what is p dot first, it's 1. If I ask you what is p dot second, it's actually 4. If I ask you p dot second dot first, it's actually 3. This will be the output if I write C out. Okay. Now what if I declare, now as of now you would have been declaring arrays like integer array, right? Or character array or something like a string array. But can I declare a pair array? Yes, you can declare a pair array. The data type can be anything. Pair can also be data type. Now this is the index 0. This is the index 1. This is the index 2 now. So you are storing pairs in your array indexes as of now. So pair can be treated as a data type. It generally lies inside the utility library. Yes, it lies inside the utility library. Okay. Now if I'm trying to access array 1, so that's basically this dot second. Now of this guy, which is the second, that's 5. So if I'm trying to print this, this is going to print 5. So this is the entire knowledge of pair that is required in order to get started with data structures and algorithms. And the next part, we'll be learning about vectors. So the first container that we will be learning is vectors. Please understand every possible function about vectors, because these functions will be similar in all the other containers like queue, list, map, set. So please make sure you understand all the functions in vector in depth. So till now, if I ask you to store 5 values, the normal thing you would have done was you would have declared an array of size 5, and that will be giving you access to 5 possible indexes, right? If you remember well enough, this gives access to 5 possible indexes, the first one being 0, the second one being 1, 2, 3, 4. Now, but afterwards, if you want to modify it, like if I want that, I want to enter one more element, I cannot modify the size of this array, because this array has been declared of size 5, and I cannot modify the size because arrays are constant in size. So this is where something like vector comes in. Vector is a container which is dynamic in nature. Like you can always increase the size of the vector whenever you wish to. So if there is a requirement where you do not know the size of a particular data structure that will be required, that's when you think of a vector, and that is the best place to use vector. So vector is a container only, okay, which stores elements in a similar fashion as the array does, okay. Now in order to declare vector, it's very simple. You just give the vector name, then you give the data type. It can be integer, double, char, string, anything, and then you declare the data type name. Like over here, it's V. It can be Raj, it can be Striver, it can be Vec, it can be ABCD, it can be anything, okay. So right after that, there's a function as pushback. So if you're saying pushback of 1, what it does is, this line basically does is, it creates an empty container. Remember this, it creates an empty container. In the next line, it says pushback of 1. So this empty container says, okay, I'm empty, so I'm going to take 1 into it. So pushback of 1 will do this. I'm going to take 1 into it. Now there is another function as emplace back. What do you mean by emplace back? It's a similar to pushback. It is similar to pushback. So the moment you do emplace back 2, it dynamically increases its size and inserts 2 at the back. It dynamically increases its size and pushes 2 in the back. Now generically, emplace back is faster than pushback. Now you can find the reasoning why in Quora. I'll be leaving the link in the description, okay. Now this is how you can define vector. Now, can we define vector of a paired data type? You can again define vector of a paired data type, as I said. So what you just need to do is you need to change the data type declaration inside this. So if you just change it, you can always, but over here there is a trick. As I said, there are a couple of ways in which you can insert elements into vector. One was pushback, the other one was emplace back. So if you're using pushback, you have to insert like 1, 2. You have to give the curly braces in order to enter, like in order to insert a particular pair. But if you're using emplace back and you write without curly braces 1, 2, emplace back automatically assumes it to be a pair and takes it as an input and inserts into the vector that you have defined. So that is how emplace back is different from pushback in terms of syntax. Now, what if I want to declare a container with a lot of elements already filled? So imagine this is the size. Now, this is how you can also declare something of a size. Like this is the size that you can give. So what happens is a container containing 100, like containing 5 instances of 100 is already defined. Yes, a container containing 5 instances of 100 is already defined, where this is the 0th index, this is the first index, this is the second index, this is the third index, and this is the fourth index. So a container of size 5 is already defined with 5 instances of 100. What if I don't want to declare with 100? You can just declare of this. If you do this, what happens is a container of size 5 with 5 instances of 0 or any garbage value is declared. Now this depends on the compiler, okay. That's how you can easily do it. So similarly, if I do something like v1 of 520, this will declare a container of 5 instances of 20, okay. Now what if I want to copy this container into some other vector of 20? If you do this and auto and enter have two vectors, you need a data type. You can again define vector of a paired data type, as I said. So what you just need to do is you need to change the data type declaration inside this. So if you just change it, you can always, but over here there is a trick. As I said, there are a couple of ways in which you can insert elements into vector. One was pushback, the other one was emplace back. So if you're using pushback, you have to insert like 1, 2. You have to give the curly braces in order to enter, like in order to insert a particular pair. But if you're using emplace back and you write without curly braces 1 comma 2, emplace back automatically assumes it to be a pair and takes it as an input and inserts into the vector that you have defined. So that is how emplace back is different from pushback in terms of syntax. Now, what if I want to declare a container with a lot of elements already filled? So imagine this is the size. Now, this is how you can also declare something of a size. Like this is the size that you can give. So what happens is a container containing 100, like containing 5 instances of 100 is already defined. Yes, a container containing 5 instances of 100 is already defined, where this is the 0th index, this is the first index, this is the second index, this is the third index, and this is the fourth index. So a container of size 5 is already defined with 5 instances of 100. What if I don't want to declare with 100? You can just declare of this. If you do this, what happens is a container of size 5 with 5 instances of 0 or any garbage value is declared. Now this depends on the compiler. Okay, that's how you can easily do it. So similarly, if I do something like v1 of 520, this will declare a container of 5 instances of 20. Okay, now what if I want to copy this container into some other vector? So you just need to declare another vector v2 and you need to pass on this particular vector v1. So v2 will be the similar container but a copy of it, like a copy of it, not the same one. It will be another container of 5 instances of 20. So this is how generically the declaration is. If you know these kind of declarations, it does work. You don't need to declare any further. Now you might be thinking, but Striver, what if we define the size of the vector to be 5? Can we increase it afterwards? Yes. Even after this, you try this line push back 1. After this line, if you try this, it increases its size and inserts 1 at the back. Yes, even if you try this line, after this, it will increase its size and expand to a size of 6. So it is allowed. It's dynamic in nature. You can always increase the size of vector even if you are predefining the size to be 5. Remember this. Now, how do you access elements in a vector? One of the easiest ways is, imagine your vector is like having 20, 10, 15, 5 and 7. Imagine this is what your vector as of now is, the container as of now is, and this is the 0th index. As I told you, this is the first index, second index, third index and fourth index. The best way to access them is you can say v1. So if you say, similar to array, if you say v1, it means 10. This actually means 10. If you say v3, it actually means 5. So you can actually access it in the similar fashion as you do for an array. Okay, that's how you can access it. That's one of the ways. Like you can write directly v0, or you can write v dot add. Generally, people don't use this, so you can just avoid it. You can simply use the stuff that you use in array. Okay, what's the other way? The other way is an iterator. Yes, the other way is an iterator. Now, I was telling you that through the lecture we will be learning about containers and iterators. So let's understand iterators. What is an iterator? Imagine the vector, like let's take the same vector only 15 and 6 and 7. Imagine this was the vector. Okay, now if I write, like for iterator you have to write this, whatever data type you have taken, vector, that data type, double colons, and you have to write iterator, and this can be anything. This can be it, this can be byte, this can be anything. This is just a name, but the syntax is the data structure, data type, double colon, iterator, this, and you write v dot begin. So iterator basically means it points to the memory address, because these guys would be stored somewhere in the memory. Like this 20 would have been somewhere stored in the memory, right? And that memory can have any address. The address can be 800567 something something. The memory address can be anything. This 10 will be right after that. This 15 will be right after that, right? So all these possible values are actually stored in memory. So what we do is, if we write v dot begin, it actually points to that memory. It points directly to the memory, right? Not to the element. It points to the memory. Understand that. V dot begin means it's pointing to here, but on the memory. Okay. So if you're trying to print v dot begin, you're printing the memory address, not the element. And in order to access, like if you have read about C++, in order to access anything that is in the memory, you just write star. Like if I write star v dot begin, understand this. V dot begin is going to give you the memory, this portion. And the moment you write star, the element inside this is accessed. Now, let's understand again. If I'm writing v dot begin, this is actually pointing to the memory where 20 is. Okay. The next time I'm saying, hey, iterator, can you just move ahead? So this begin does this goes here. So now the iterator, instead of begin, is right at the next memory address, because I've shifted the memory, and inside all of these are contiguous memory locations. All of these are contiguous memory locations. So if you are shifting it plus plus, it moves to the next memory. Again, if you do it plus plus, moves to the next memory. After that, if you're doing star of it, what will happen? What will happen? As of now, it was 20. So if you do star of it, this actually prints 10, because it has shifted to 10, and now you're saying star, access the value at that memory. So you get 10. I hope that makes sense. Okay. What if right after this, I do an it plus 2? So basically, I'm saying shifted by 2 positions to this portion. Shifted directly by 2 positions to this portion, which has a 6. Now, if I try to print this, it will print 6. So this is how you can easily use the iterator. Iterator is nothing but points to the memory where the element is lying. I hope that makes sense. Okay. So we are talking about iterators. Now you must be thinking, do we have any other iterators apart from begin? We do have. We have something like end, reverse end, and reverse begin. Okay. Now imagine I have something like 10, 20, 30, 40 as the vector. Okay. So this is what the vector is. So if I'm saying vector dot end, like where does this point to? Remember this, end will not point to this portion. End will not point to this portion. Instead of that, end will point to somewhere right after 40. The memory location that is after 40. Now, if you on this iterator do an it minus minus, then this iterator will move to 40. Then only this will move to 40. So end points to a memory location that is right after the last T. So okay, so again, we have something like end, reverse end, and reverse begin. Okay, now imagine I have something like 10, 20, 30, 40 as the vector. Okay, so this is what the vector is. So if I'm saying vector dot end, like where does this point to? Remember this, end will not point to this portion. End will not point to this portion. Instead of that, end will point to somewhere right after 40. The memory location that is after 40. Now, if you on this iterator do an IT minus minus, then this iterator will move to 40, then only this will move to 40. So end points to a memory location that is right after the last element. Please understand, this is very, very important in terms of iterator. So you understood about end, but what about something like reverse end? Now these couple of things are never used, but just know it, like it's never ever used. What is reverse end? Reverse end basically means I am going to reverse this. I'm going to reverse this. So apparently the reverse is 40 at first, then 30, then 20, then 10. So now the end is 10. So right after end. So that's this position is where it will be pointing. That's this position is where it will be pointing. Reverse end. End means right after, right? And reverse begin will be pointing to this. Reverse begin will be pointing to this. Now there is a specific thing about this. It moves in the reverse way. Now if I try to do IT plus plus on this, if I do IT plus plus, IT as of now is pointing here. IT plus plus will move here. Yes. And after this, IT plus plus will move here. So it's a reverse iterator. You have to think it in the reverse way. Like if you just think this array in the reverse, it's 40 vector rather, 40, 30, 10, 20, 10. And now if I talk about end, this is end. And if I talk about begin, this is begin. And if I say begin plus plus, it moves to 30. So it's that way. Reverse. Everything is in the reverse order. Never used. Do you need to know? Just know it for the sake of knowing, but no one is going to ask you. We have discussed about v of 0, v of at of 0. What is v dot back? As the name recommends, if the vector is having something like this, v dot back means the element which is at 30 is the element which is at 30. That is the meaning of this. Now, if I'm wanting to print the vector, there are a couple of ways. Imagine I have 10, 20, 30 as the vector, and I want to print it. The simplest way is I know the indexes are 0, 1, 2. So I can directly loop from 0, 1, 2. Like I can just go across and say, ki I'll loop from 0, 1, 2 and print it. That's a very simple way. The other thing is I say, I'm going to do it iterator wise because I know this guy is begin. So I write begin and I know the last guy is end. Right after the last guy is end. So I'm going to run the iterator till it does not reaches the last guy. I'm going to do an IT plus plus. The first time I get 10, next I move it, I get 20, next I move it, I get 30, and I will print every time star of IT. And this is how you can print the entire vector. This is how you can print the entire vector. But there is a shortcut. Now you must not be like, no one wants to write these long syntaxes because STL means short, like standard template library, but it means everything in a very simpler fashion. So STL gives you something like auto. So if you write auto, it automatically assigns it to a vector iterator. You don't have to say that this is a vector iterator. You don't need to define the data type. It automatically defines the data type. Now, even if you write integer a equal to 5, so you're defining a to be of integer data type. Even if you write something like auto of a equal to 5, computer automatically says that this is an integer. So this a will be of integer data type. So if you write auto, the data type is automatically assigned according to the data. According to the data type is automatically assigned. Like if this would have been something like Raj string and I would have written auto of a would have been automatically string. So auto means auto assignation. So that's the beauty of C++. If for some time you don't know the data type, you can just write auto. C++ will take care of it and it will automatically assign the data type for you. The other way to print the vector is using the for each loop. So if I use this for each loop, which is IT on V. So it basically means if the vector is 10, 20 and 30, I'm saying IT. First time IT is here, next time IT is here, next time IT is here. And you can simply print the IT. Auto means on the data type. Please iterate on the data type. First iterates on the 10, not an iterator, not an iterator. This means over here int because it is of integer data type. Automatically iterate 10, then 20, then 30 and automatically prints it entirely. So that's about over here on V is using the for each loop. So if I use this for each loop, which is IT on V. So it basically means if the vector is 10, 20 and 30, I'm saying IT. First time IT is here, next time IT is here, next time IT is here. And you can simply print the IT. Auto means on the data type. Please iterate on the data type. First iterates on the 10, not an iterator, not an iterator. This means over here int because it is of integer data type. automatically iterate 10, then 20, then 30, and automatically prints it entirely. So that's about how to declare a vector, how to use iterator in a vector, how to print a vector. Now let's understand the deletion in a vector. So imagine I want to delete something. So there is something as an erase function. And if I have the vector like 10, 20, 12, 23, I say begin dot plus 1. Now in order to use the erase function, there are a couple of things. Either you give the iterator that like the location of the address that you want to delete, that this is the address that I want to delete. Please delete this address. So I'm saying, okay, begin plus 1. What does this mean? Begin plus 1 means 20. So if you just do erase of this address, so the vector will be now 10, 12, 13. The vector will be reshuffled. The vector will be reshuffled into 10, 12, and 13. That is how the reshuffling will go on. So that is one way to erase. So we have understood how to erase single element. But what if I have a vector like 10, 20, 30, and 40, and 50? And I say, Striver, I want to delete these couple of elements. I don't want to go single. Do you have something? I say, yes, I have. And that's like erase. And I say, give me the starting address and give me the end address after the element. Very important. End address after the element. So starting, if I want to delete 20, can I say that's nothing but begin plus 1? I can say, because right after begin, that is where 20 is. I want to delete 30. That is begin plus 2. But I said right after, what do you want to delete? So that's begin plus 3. That's begin plus 3. 3 is pointing to here. So I want to delete this portion, but you have to give this end after the guy that you want to delete. After, right after 30, you have to give the address. So apparently, it deletes start, and this is something like this end is not included. So understand the deletion in a vector. So imagine I want to delete something. So there is something as an erase function. And if I have the vector like 10, 20, 12, 23, I say begin dot plus 1. Now in order to use the erase function, there are a couple of things. Either you give the iterator that like the location of the address that you want to delete, that this is the address that I want to delete. Please delete this address. So I'm saying, okay, begin plus 1. What does this mean? Begin plus 1 means 20. So if you just do erase of this address, so the vector will be now 10, 12, 13. The vector will be reshuffled. The vector will be reshuffled into 10, 12, and 13. That is how the reshuffling will go on. So that is one way to erase. So we have understood how to erase single element. But what if I have a 12 and 32 is begin, so the address that you want to delete, that this is the address that I want to delete. Please delete this address. So I'm saying, okay, begin plus 1. What does this mean? Begin plus 1 means 20. So if you just do erase of this address, so the vector will be now 10, 12, 13. The vector will be reshuffled. The vector will be reshuffled into 10, 12, and 13. That is how the reshuffling will go on. So that is one way to erase. So we have understood how to erase single element. But what if I have a vector like 10, 20, 30, and 40, and 50? And I say, Striver, I want to delete these couple of elements. I don't want to go single. Do you have something? I say, yes, I have. And that's like erase. And I say, give me the starting address and give me the end address after the element. Very important. End address after the element. So starting, if I want to delete 20, can I say that's nothing but begin plus 1? I can say, because right after begin, that is where 20 is. I want to delete 30. That is begin plus 2. But I said right after, what do you want to delete? So that's begin plus 3. That's begin plus 3. 3 is pointing to here. So I want to delete this portion, but you have to give this end after the guy that you want to delete. After, right after 30, you have to give the address. So apparently, it deletes start, and this is something like this end is not included. The start is included. Got it? So please make sure you give something as which is not included right after that. Okay? So that's how you can easily delete it. Okay, so for this example, we have 10, 20, 12, 23, 35. What do you mean by plus 2? That means 12. What do you mean by plus 4? Plus 2, plus 3, plus 4. So plus 4 is here. So apparently, this and this will get deleted, and you will be left out with 10, 20, and 35. I hope that makes sense. Now we're going to learn about insert function. Insert. Again, if you want to insert something, it's very simple. First of all, if you declare this creates 100, like two instances of 100 in a container. Now, if I want to insert 300 right at the start, So I say dot begin and please insert 300. So this does is, this inserts right at the beginning, okay, 300. Now imagine you had like 10, 20, 30, 40, okay, and I want to insert something here. I want to insert a 5 here. So what do you write? Now, this is the first position. So instead of begin, you have to write begin on the first position. Can you please insert 5? So if you write this 5 will go here and get inserted right at the first position. That's how you do insert. Now that was for single element. You inserted single element. What if I say that you have 10, 20, 30, 40 as the vector, and I want to insert two fives. Imagine I want to insert two fives. How do you do that? So you say I want to insert at the first position the number of elements that I want to insert and the number that I want to insert. So this will do is, this will take 5 and 5 and insert it right after 10. So this makes it 10, 5, 5, 20, 30, 40. So if I say over here, you had 30, 100, 100. So I'm saying begin plus 1, which is right after 300. Two positions, like two occurrences of 10. So two occurrences of 10 inserted. Understood? Very simple. So that's how the insert function does work for this. Now what if you have a vector and you want to insert it into some other vector? Now imagine I say that, okay, I have a vector like, for this example, we have 50, 50. So I had a 50 and 50 vector. Okay, now this vector is named as copy. So this is the line that declares that. Okay, now I already had this vector 30, 10, 10, 100, 100. And now I want to insert this 50, 50 somewhere. So at that somewhere, I give that address and I say, please enter this entire vector. Please enter this entire vector. So it will easily take this entire vector and enter it. If you want to have a portion of this vector, you can give that starting portion and you can give this after end portion, and that will also. At that somewhere, I give that address and I say, please enter this entire vector. Please enter this entire vector. So it will easily take this entire vector and enter it. If you want to have a portion of this vector, you can give that starting portion and you can give this after end portion, and that will also do it. Again, not required. What is required is erase and this portion. This is hardly required. If you just know erase and insert about a single element, does. Okay, that's how you can easily do about vector. Now what are the other functions in vector? V dot size will give you how many elements are there in the vector as of now. Dot pop back, if this is the vector, pops out the last element. Dot swap is very simple. If this is a vector v1, this is a vector v2, it swaps the vector as the name. Recommends v dot clear. Doesn't matter how big your vector is, trims it down to an empty vector, erases everything. Okay, and v dot empty says, does your vector, like if your vector also has like a minimum of one element, it says not empty, but if the vector has nothing, it will say true, empty. So these are the functions that are generically required in a vector. So the next container that we will be learning is list. Now list is exactly similar to vector, but the only stuff in list is it gives you front operations as well. Now list is a container, again dynamic in nature, same way of declaration. You can push back 2, you can emplace back 4. So this is the list that will happen if you push back 2 and 4. And after that, if you say push front, this front goes over here 5, like it directly pushes it into the front. In vector, you had to use the insert operation, and if you're inserting somewhere, that does take a lot of time. Like insert function in a vector is very costly. Like we will read about time complexities in further data structure algorithmic lectures, but as of now, just remember, an insert in a vector is costlier. And in list, since the internal operation is a doubly linked list, like a doubly linked list is maintained for a list, and for a vector a singly linked list is maintained. So thereby something like push front is very very cheap in terms of complexity, time complexity wise, when you compare it to a vector. Okay, and there is emplace front as well. All of the functions, begin, r end, reverse end, size, clear, empty, all of the functions are similar to vector, so I'll not be explaining that. Okay, so that is about list. Now the next container that we will be talking about, be explaining that. Okay, so that is about list. Now the next container that we will be talking about is DQ. Again, similar to list and vector, you just declare it, push back, push front, pop back, pop front, back, front, and all of the functions are similar. I'm not going to explain this as well. It is exactly similar to list and vector. So the next container that we will be learning is stack. Now stack is something as LIFO. LIFO means last in. Remember this: last in, first out. The guy who went in last is the guy who will come out at first. So generically, you can just imagine a stack to be a data structure like this, and this is how you declare a stack. Stack, the data type, and the variable name. Okay, so I've declared the variable name like this. I'm saying push one, so I push one. I'm saying push two, I push two. I say push three, I push three. I'm again saying push 3, I push 3. I say in place is similar to push, so I say push 5. Now, these are the push operations. Right after that, if someone says stack.top, so as I said, who's the last guy who went in? The last guy that went in, is nothing but 5. So this will print 5. Yes, this will print 5. Now realize this over here, indexing access is not allowed. You cannot say this is index 0, this is index 1. Something like this you cannot say. In stack, there are only 3 functions. One is push, one is pop, the other one is stop. All other there, like size, clear, are there, but these are the generic 3 functions that you have to deal with. So if I'm saying top, it gives you 5, but the 5 is still in the stack. The 5 is still in the stack. Now the moment I say pop, it deletes this from the stack. Now 5 is not in the stack. Now if I'm saying top, right before 5 was there? 3. So it prints 3. Now if I'm at this moment saying stack.size, there are 4 elements. So I print 4. If I'm saying stack, is the stack empty? The answer is false. It has 4 elements. Now if I'm saying swap it to some other stack, I declare another stack 1, and I say, can you please swap it? So swap is very understandable. Both the guys will swap. So I hope push is clear, pop is clear. Pop means delete. Top means just tell me what is at top. You don't need to delete. Just tell me what is at the top. So that is how the stack STL works like. Now talking about complexity wise in stack, all the operations are big O of one operations. Everything happens in constant time. So let's learn about the next container. Now. Now the next container that we will be learning is a queue data structure. Now a queue data structure is similar to stack, but over here it is FIFO. Okay, FIFO means first in, the guy who gets in first comes out first. Stack was last in. Okay, now you can just think it in this way, like if you're forgetting names, you can say like you go into a platform and if you're buying a ticket, what do you generally do? The person comes in, the first person who comes in stands, and the next person who comes in and stands. So the first guy who gets the ticket, this guy, then this guy gets the ticket, and if someone is coming, it's a queue that happens. So that is where the concept comes in, first out. So if I'm saying push one, I push one, push two, I push two, push four. So I pushed 1, 2, and 4. And the next line I'm saying q dot back plus equal to. But back will mean 4. It does not mean this guy. Back will mean 4 only. So over here I'm saying add plus 5. This makes it 9. I'm now saying q dot back. So if I'm saying q dot back, it prints the last guy 9. Okay. If I'm saying q dot front, prints 1. Just prints, does not deletes. If I'm saying q dot pop, deletes the front guy, first 10 guy. Q dot front is now 2, so it prints 2. It is similar. And now all the operations are much more similar to stack size and all these things. That's how Q works. Again, all the operations are happening in constant time. Now, the next thing that we will learn is priority queue. Now, as the name recommends, priority. The guy who has the largest value stays at the top. It's similar to queue, but there is something that happens inside which you learn probably after a couple of years when you are appearing for interviews. But as of now, just understand the logic. Okay. So remember, if you're declaring priority queue like this, the maximum element stays at the top, or the largest element. If you're using character, the largest character. If you're using integer, the largest integer. If you're using the string, the lexicographically largest string will stay at the top. Okay, so I'm saying q dot push 5. So you push in 5. I say q dot push 2. So you push in 2. I say q dot push 8. So you push in 8. Now I say q dot push 10. So you push in 10. Okay. Now the moment I say pq dot top, out of all these elements, which one is the largest? 10. So it prints 10. And that is the guy who will be at the top. Now if you are trying to insert something like 3, the 3 will go right here. The 3 will go right here. And this is not a linear data structure. Inside of it, a tree data structure is maintained, which you'll learn in the later half. Now, understand one thing: the data is not stored in a linear fashion. In like inside, at inside a tree is maintained. Okay, which probably you'll learn someday. Okay, so as of now, if I say pq dot pop, the topmost element is popped. 10 is popped. If I say again no pq dot top, who's the topmost? 8. Yes. So this is This is how the priority queue works. Again, push, top, and pop. Main functions. The other ones are size and empty. Size and empty is very simple, and swap is also very simple. So these are the functions. What if I want a priority queue which stores the minimum element at the top? Then this is how the syntax is. Priority queue, data type, vector, and this greater int you have to write. And if you give this data type, and now if you push 5, 5 is there. If you push 2, 2 is there. And if you push 8, 8 is there. If you push 10, 10 is there. But this time if you try to access pq.top, 2 will come out. So that's how you maintain a very simple minimum priority queue. And generally it's known as mean heap, and this is known as max heap. Remember this, the terms that you learn in DS algo as you move forward. What is the time complexity of push? Push happens in logarithmic of n, top happens in big O of 1, and the pop, which is the deletion, again happens in logarithmic of n. So this is how it happens. If you don't know what is logarithmic of n, no issues. Just keep this in your mind as you move forward. You will understand in DS algo. Now the next container is very, very interesting, and that is nothing but the set container. Now what is set? Just remember one thing. It stores everything in the sorted order and stores unique. Just remember these couple of points and you know what is a set. Everything in the sorted and just unique. Just 2 points and you're done. Let's understand. So imagine this is the container, okay? And I say insert 1, so you insert 1. Imagine you say emplace 2, so you insert 2. Imagine you say insert 2, unique. So will it store 2 again? No, it does not. No, it does not. It does not store 2. If I say insert 4, will it? Yes. If I say insert 3, it will. But it will insert it here. Again, a very important thing. Sorted. Stores in a sorted order. At first, it will have 1. Then it will have 2. Then it will have 3. Then it will have 4. Everything in the sorted fashion. So it stores everything in the sorted fashion. So this is how the set will be storing. Again, a container. Is it a linear container? No, a tree is maintained. So I'm just explaining you this via this bucket, but inside of this there is an entire tree which is maintained, again which you learn as you move forward. So insert and place works in a similar fashion, sorted and unique. Okay, now there are functions. If I say set.find 3 and this is the set, so it will return an iterator. Remember this, returns an iterator which points to this 3, which points to this 3. It returns an iterator which points to this 3. Okay, so basically this is an iterator. Remember, iterator points to the address. Perfect. Now if I say set.find 6, is 6 here? No. If an element is not in the set, please hear me out properly. If an element is not here in the set, it will always return set.end. That means an iterator which points to right after the end. Imagine the set is having 1, 2, 4, 5, and you did set.find 3. Okay, and you don't have a 3. So you will have an iterator end. This is the iterator which points after 5. After 5. That's where dot find will return the iterator to be. It points afterwards. Okay, and after this there is set.erase. Very simple. Erases this guy 5. Erases this guy 5 out of it. Like if this is the set, if this is the set, it will delete 5. It will simply delete 5. You don't have to think anything. Deletes 5 and maintains the sorted order. Deletes 5 and maintains the sorted order. Now, as I said, set is nothing but unique and sorted. So if you're trying to count, if it exists, it will only have one occurrence because it does contain unique. And if it does not exist, it will have 0. So if 1 is there in the set, it will give you 1, like 1 occurrence. If it is not, it will give you 0. As simple as that. Okay. You can also erase, like you can either give the element to be erased, like you can give the element to be erased, or you can give that, okay, this is the address or the iterator. Please go and erase this iterator. As simple as that. Now, in vector, we did learn about erase, start, comma, end. Similar thing also works over here. If you want to erase everything, yes, if you want to erase everything between 2 and 4, imagine you had something like this. So 2 is here, 4 is here. If you give the first guy, if you give the second guy. So if you do find, you'll get the 2's iterator. If you do find a 4, you'll get the 4's iterator. So it deletes 2 and 3. Remember this, it deletes 2 and 3. Not find. If you can give that, okay, this is the address or the iterator. Please go and erase this iterator. As simple as that. Now address, give, and if it does not exist, if it set, it will delete 5. It will simply delete 5. You don't have to think anything. Deletes 5 and maintains the sorted order. Deletes 5 and maintains the sorted order. Now, as I said, set is nothing but unique and sorted. So if you're trying to count, if it exists, it will only have one occurrence because it does contain unique. And if it does not exist, it will have 0. So if 1 is there in the set, it will give you 1, like 1 occurrence. If it is not, it will give you 0. As simple as that. Okay. You can also erase, like you can either give the element to be erased, like you can give the element to be erased, or you can give that, okay, this is the address or the iterator. Please go and erase this iterator. As simple as that. Now in vector, we did learn about erase, start, comma, end. Similar thing also works over here. If you want to erase everything, yes, if you want to erase everything between 2 and 4, imagine you had something like this. So 2 is here, 4 is here. If you get the first guy, if you get the second guy. So if you do find, you'll get the 2's iterator. If you do find a 4, you'll get the 4's iterator. So it deletes 2 and 3. Remember this, it deletes 2 and 3, not 4. 4 is this bracket and this is this. Please remember this. Now in set, there are other functions like size, empty, swap. Everything is similar to vector. There is begin. All of these are similar to vector. So I will not be explaining them. The most important are find, count, and insert. These are the most important ones, and as well as erase. Now they have something as a lower bound and an upper bound. So I will be linking a video in the description which explains lower bound in depth and upper bound in depth. So please go back and watch lower bound and upper bound. Once you have seen that, you will actually understand how does this lower bound and upper bound work in a set. It's the exact same that will be taught in the video which is in the description. So please make sure you watch it. Now in set, will be taught in the video which is in the description. So please make sure you watch it. Now in set, everything happens in logarithmic time complexity. If you're inserting, it takes logarithmic. If you're erasing, it takes logarithmic. Everything happens in a logarithmic time complexity. Again, if you don't know login, no issues. Please remember this in your head. Now we did learn about set, and I said sorted and unique. That means it will just contain one occurrence of 2. You can insert thousands of occurrences of 2, but it will just store one occurrence of 2. But there is something as multi-set. If you define multi-set, it only obeys sorted and it will not obey unique. It will store multiple occurrences. Like if you try to insert 1, 1, 1, stores all the occurrences. And if you try to erase 1, but all the occurrences are erased this time. But if you do an erase 1, it erases every one. And this time count will count you the number of ones in the multi-set. But if you want to delete, imagine your multi-set is containing 3 ones. And I just want to delete 1 occurrence of 1, or 2 occurrence of 1, or 3 occurrence of 1. So what I can do is, I can just find out the first occurrence of 1. So I'll just do multiset.find, because I know find points to the iterator. And I'll say erase that iterator. Instead of saying erase element, because if I say, understand, if I say erase element, it erases all the elements. But if I say erase address, it only erases that portion. It only erases that portion. And I want to erase like two ones. So I say find 1 and go till 2. Go till 2, so it will erase both of them. Both of them. So either erase element, erase address, or erase starting address and right after the end. That's it, the iterators. And rest all functions are same as set. Stores everything in the sorted, but not unique. Stores multiple occurrence like 1, 1, 1, 2, 3, 3, 4. It can store multiple occurrences as well. So that is the definition of multi-set. Now we did learn about set. We did learn about multi-set. Now there is something as unordered set. Everything is similar to set. The only thing that is omitted, like it stores unique, The only thing omitted is it does not stores in the sorted order. We don't know how it will store. It has randomized order. It has randomized order. Like if I put in 1, after that I put in 5, after that I put in 2, after that I put in 3, after that I put in 6. It can have this order, it can have any order in the world, but it will just have unique elements. Like if I try to insert 1 again, it will say I have 1, I have 1. And in most of the cases, the time complexity is big O of 1. Everything, like all the operations are same. Insert, erase, all the operations are same, but only the lower bound and upper bound function does not work. All the operations work, but the lower bound and the upper bound functions do not work. Remember this, all operations are similar to set, and they do not store everything in sorted order. So all the operations are generically in a big O of 1 constant time, but in the worst case, which happens once in a millennium, like if the data is like possibly given in such a way that they want you to explore the worst case, which does not happen, then the unordered set goes for a big O of an linear time. It goes for the worst case. Again, does not happens every day, happens once in a blue moon. The time complexity goes till big O of n. You can just write them down in notes. You will understand these things when you move across or when you grow in experience. That's how the unordered set works. So the next container that we will be learning is a map container. Okay. Now you can think this as something like, just take a task where I say in your college, there will be like, there might be multiple people with Raj name, but how do you distinguish themselves? By roll numbers, right? One Raj might have a roll number of 23. The other Raj might have a roll number of 25. The other Raj might have of 28. So, this one guy is of roll number 23. The other guy is of roll number 25. The other guy is of roll number 28. So, generally, this is in your class, this is stored like this: roll number 1, roll number 2, roll number 3, and so on. If there are 50 people, you store it like this. So, map, you can think this as a data structure or a container which says the roll number is my key, and over here the value can be the name. So this is what the data structure means. You store unique keys because you can't have 23 roll numbers twice. You can have it just once. So the keys are unique. The keys are unique, but the values can be like, over here there can be a Raj, over here there can be a Raj. So there is one guy with key 3 who is Raj, there is one guy with key 50 who is Raj. There can be duplicate values, but it has to be a unique key. So you can think map as a container which stores everything in respect of key and values. And very important thing, this key can be of any data structure. It can be integer, sorry, any data type. It can be integer, it can be double, it can be pair, it can be anything. Similarly, this value can be anything. So how do you define map? This is key, this is value. Key is integer, value is integer. Over here, key is an integer, and they're saying value is 2 integers. Over here, they're saying key is 2 integers and value is 1 integer. So you can define it as you wish to, that is on you. This is how you define. Okay. Now, if I'm defining the map to be this, for an example, assume you're defining the map to be this. Now I say 1 equal to 2. It means on the key 1, can you please store 2? So this is what it stores internally in the map. Internally in the map, it stores 1 comma 2. Next I say, I don't want to store it like this. Emplace 3 1. So it stores 3 is the key and the value to 3 is 1. It does the similar thing, stores it into the map. Store 2 for on you. This is how you define. Okay. Now, if I'm defining the map to be this, for an example, assume you're defining the map to be this. Now I say 1 equal to 2. It means on the key 1, can you please store 2? So this is what it stores internally in the map. Internally in the map, it stores 1 comma 2. Next I say, I don't want to store it like this. Emplace 3 1. So it stores 3 is the key and the value to 3 is 1. It does the similar thing, stores it into the map. Again I say insert. You can also use insert. 2 comma 4 goes and stores 2 comma 4. And this is how you can store all these 3 variables. Okay. So in this way, you can actually store for this particular declaration. And remember one thing, map stores unique keys. Very, very important. Map stores unique keys in sorted order, something similar to set data structure. Map stores unique keys in sorted order, something similar to set data structure. Okay, now this is the declaration, the second declaration. For this declaration, this declaration, this is the key. So you have declared the key like this, and the value is a single integer. So this is it. For this, it will be storing like, okay, key is 2 comma 3, so this is stored, and the value, corresponding value is 10. Perfect. So this can be stored like this. That's how it generically stores. Okay, I hope that makes a lot of sense. I told you that everything is stored in a sorted order. So this will at first store 1 comma 2, then it will store 2 comma 4, then it will store 3 comma 1. This 3 lines will be storing like this. So again, if you want to explore, or if you want to iterate on the map, one of the ways is you start from begin iterator and you go on till end iterator, similar in the vector. Or you do is you say it, you run a for each loop. First time it is here, so it stores in a pair. Next time it is here, it stores in a pair. Next time it is here, it stores in a pair. If it is storing in a pair, this is it dot first and this is it dot second. So first time prints 1 2, next time goes here, prints 2 4, next time goes here, prints 3 1. So if you try to do this cout, this is how you can actually traverse in a map, and everything is stored in a sorted order of key. In a sorted order of key, not value, sorted order of key. Remember this, sorted key is how it stores, no duplicates, all uniques. Okay, now if I want to access map of 1, if I want to access map of 1, it says a value 2. It says a value 2 because at 1 you're storing 2. But if it tries to access 5, will it find 5? There is no 5. So what happens is it says null. But if you want to print it, it actually goes and prints 0 or null. Okay, because it does not exist. So if something does not exist, it gives you 0. Okay, so this is how you can easily access for a key. Now if it goes and print sorted order of key, in a sorted order of key, not value, sorted order of key. Remember this, sorted key is how it stores, no duplicates, all uniques. Okay, now if I want to access map of 1, if I want to access map of 1, it says a value 2. It says a value 2 because at 1 you're storing 2. But if it tries to access 5, will it find 5? There is no 5. So what happens is it says null. But if you want to print it, it actually goes and prints 0 or null. Okay, because it does not exist. So if something does not exist, it gives you 0. Okay, so this is how you can easily access for a key. Now if you want to know the iterator, imagine you want to know where the key 2 lies, the address of it. So again, the find function will come over here and say map.find3. So this is where you get it, the iterator. And in order to access this, you give a star. So this accesses this. And if you want the value, dot second. Got it? It gives you the iterator to the this 3 comma 1. Got you 3. So this is it. Next time ID is here, it stores in a pair. Next time ID is here, it stores in a pair. If it is storing in a pair, this is it dot first and this is it dot second. So first time prints 1 2. Next time goes here, prints 2 4. Next time goes here, prints 3 1. So if you try to do this cout, this is how you can actually traverse in a map, and everything is stored of its access 2 bit. There is one prints 0 5 to 1 you're storing 2. But if it tries to access 5, will it find 5? There is no 5. So what happens is it says null. But if you want to print it, it actually goes and prints 0 or null. Okay, because it does not exist. So if something does not exist, it gives you 0. Okay, so this is how you can easily access for a lies the address of it. So again, the find function will come over here and say map.find3. So this is where you get it, the iterator. And in order to access this, you give a star. So this accesses this. And if you want the value, dot second. Got it? It gives you the iterator to the this 3 comma 1. Okay, this it is this. So if you give a star, it's the element. And if you give a second, it is the 1. That's how you can easily access this as well. Now over here, if you try to do dot find 5 and 5 is not there, it points to nothing but dot end. End means after the map. After the map. Okay, makes sense? And again, the lower bound and upper bound functions, if you have seen the video in the description, you can understand how lower bound and upper bound works, okay? And all the other functions like erase, swap, size, empty are same. So I'm not going to explain it again. Next thing is multi-map, similar to map. Only thing is you can store duplicate keys. You can store duplicate keys, something similar to set and multi-set, as I told you, right? Duplicate keys, but everything in the sorted order. This time you can store like 1 comma 2, and then you can come across and again store like 1 comma 3, right? So you can store duplicate keys over here. Unordered map, again, unordered map is similar, only this portion will go across. It will not store in sorted. It will be randomized. It will be randomized, but it will not have duplicate as well. It will just have unique keys. Unordered map will have unique keys, but it will not be sorted. And the difference is like the map works in logarithmic of time, and the unordered map in almost all cases works in constant time. In the worst case, it goes for big of n. Again, this worst case happens once in a blue moon, not always. In almost all the cases, big of 1 is what appears. So as of now, I can say that I have completed containers and iterators. Now this is not required. Not required. No need to learn it. Just omit this. Now I'll be telling you all the important algorithms, like which are mandatory, like you should know, and all the other algorithms which I will not teach. You will eventually learn while you code, but that are not like those are not important. So as of now, you can just leave it. Eventually, with time, if it's required, learn at that moment. No need to learn it now. So let's move across to learn some algorithms. Now, if I say you that, hey, listen, I give you an array of size like 1, 5, 3, 2, okay, of size 4, and I want you to sort it. So you will be like, let's apply bubble sort, merge sort, selection sort, so and so. But in C++ STL, if you just write the line sort a comma, it's a 4 size. So this actually means the first position of the first iterator, the starting iterator, and this means the last iterator. A plus 4 actually means this portion, then portion, the last iterator. Again, similar to something like start is included and end is not included. So you write the starting iterator, which is A, which actually points to this, and A plus 4, which actually points to this. So all the elements are sorted. Right after this line, it will have 1, 2, 3, 5. So you don't have to actually use merge sort, bubble sort, selection sort. It sorts that into one line. And if you're using vector, the starting is begin. This is the ending, the starting iterator and the ending iterator. So in this way, you can sort any container, not map, all not map. I'm talking about vectors and arrays over here. Okay. Now, what if I just wanted, like, I had something like 1, 3, 2, 5, and rather, let's keep it like 5, 2. Okay. And I wanted just this portion to be sorted. So I know A plus 2 because this is A plus 2 for sure. And I know A plus 4, right after this is A plus 4. So only this portion will be sorted. So this is how only this portion will be sorted. Perfect. What if I want to sort them in descending order? Imagine you have like 1, 3, 5, and 2. I want to sort them in descending order. So it's very simple. Give the starting iterator, give the ending iterator, the portion that you want to sort, and just write greater int. Yes, just write greater int. And this is nothing but a comparator, an inbuilt comparator, which automatically sorts it. Like I'll teach you comparator, automatically will sort it in the descending order like this, in a descending order. You just need to write greater int and it automatically sorts it into a descending order. Now, what if I want to sort it in some other fashion? Because as of now, we know how to sort it in increasing, we know how to sort it in decreasing. But what if I want to sort it in my way? Because going across, you will see that this my way is being used a lot. For an example, we have declared a pair array, and these are the pairs 1, 2, 2, 1, 4, 1. Okay. And I want you to sort according to second element. Like I want you to sort it in order of increasing second element. Please understand. I want you to sort it according to increasing second element. Okay. And if the second element is same, then sort according to the first element, but in decreasing. But in decreasing. What do I mean by that? So as of now, can I say the second element is 2, 1, and 1? So this 2, 1 and 4, 1 are the guys who should appear right at the first. Okay, because the second elements are 1 and 1, and after that I can say after that 1 comma 2 will appear because of this portion. So can I say that I've sorted according to the second element? But I still have a problem. Now these couple of guys are having same second element. Now if they have the same second element, I want you to sort it according to the first element, but in descending, which means I want you to have 4 comma 1 at first and then 2 comma 1. That means among them I want you to sort it according to descending. So first 4, then 2, and then you can write, so first sort it according to the second, and if there is a group which is having the same second, then among them sort it according to the first. So this is my way. This is my way. Like it's something like a combination of increasing as well as decreasing. So this is where generically you write the first iterator, the last iterator, and a comp, and a comp. Remember this, and a comp. Now this is nothing but a self-written comparator, a self-written comparator, and this comparator is nothing but a boolean function. Is nothing but a boolean function. So I've written this, but I'll just teach you how to write it. It's very simple. You write boolean comparator, and this is the function. Okay, this has to return a true and a false. This has to return a true and a false. Now go back and see what is the data type that you just had. And the data type, if you see, was pair of intent. Just copy paste and have couple of guys, pair 1 and pair 2. That's it. Have couple of guys. This is the first thing that you'll do. Have couple of guys. Now please understand this, that this is pair 1 and this is pair 2. So forget about the array. Forget about the array. And now think of just two instances where you have two pairs. Where you have two pairs. This is P1, this is P2. While writing comparator, just focus. What have you been said? Sort it according to the second element. So you say, okay, if my P1 dot second is already smaller than second, that means it's true. We are assuming that the pair 1 lies before P2. Lies before P2. That is what the assumption is. The pair 1 lies before P2, and that is okay. If the second guy is lesser than this second guy, I'm okay. They should actually. So they are in the correct order. This comparator says, are two guys in the correct order or not? And I'm saying they are in the correct order. They are in the correct order because this guy is smaller than this guy, and that is what I was said. So if they are in the correct order. But I know one thing. If it's the opposite, if this is the case, I will say they are not in the correct order. Because if I have two guys, okay, and imagine this is 5 and this is 4, and I'm saying P1 occurs before P2, this is wrong. This is wrong. If this second is actually greater than this, I know this is wrong. So I say they are not in the correct order. So what happens is comparator internally says P1 and P2 are not in the correct order. Can you please swap them? So apparently 4 comes before 5. This is what happens. So they do internal comparisons and they swap. 4 P1, this is wrong. If this second is actually greater than this, I know this is wrong. So I say they are not in the correct order. So what happens is comparator internally says P1 and P2 are not in the correct order. Can you please swap them? So apparently 4 comes before 5. This is what happens. So they do internal comparisons and they swap. So I told them false, they're not. So they will swap internally. But do we have any other conditions? We have. What if they are same? Because that's the only condition that is left. That is the only condition, because if these two conditions do not happen, I know we will come to a point that they are same. I don't need to write a if, because that's the only condition that is left. They are same. Now if they are same, we'll again try to evaluate I know if they are same, this is P1 and this is P2. And this time it is descending. So if this guy is greater than this guy, it's okay. Otherwise, it's not. So can I say if P1 dot first is actually greater than P2 dot first, it's okay. Because this is what I was looking for. Else I say it's not. If they're equal, it's fine. Even if I swap or do not swap, it's okay. So can I say if it's greater, it's okay. That's what I'm looking for. But if it's not, that's false. Please swap it. If it's not, I need it in descending. Can you please just swap it? So you just analyze everything whenever you try to write a comparator. Always analyze everything in terms of two pairs. Don't think in terms of arrays. Just pick up, yes, I repeat, you just need to do one thing. Just pick up one pair, just take another pair and try to analyze P1 and P2. That is your job. So we have learned about comparators. So anytime there is my way sorting, you can write the comparators. Just need to write this and you should be done. Just focus on the data type and try to just evaluate two data types and write it. Nothing different. Okay. So this is again one more STL which is very important, which is built-in popcorn. So if number is 7, what is the binary of 7? It's 1, 1, 1. That's the binary of 7. So as a built-in pop count, it says, okay, this has 3 bits as 1. Generally, number 7 means 0, 0, 0, 0, 0, 0. Like these are the 32 bits inside the computer. In 32 bits, it's 0, 0, 0, 0, 0, 0 and 1, 1, 1. So built-in pop count says how many ones are there or how many set bits are there. So it will return 3 set bits. If this number would have been 6, which is nothing but 110. 6 is nothing but 110. So built-in pop count would have returned 2, the number of set bits. Okay. If the number is long, then built-in pop count becomes built-in pop count LL. Built-in pop count LL if the number is long. Integer will not suffice then. Perfect. Now the last thing is, not the last, second last thing is next permutation. Now if I write a string as 1, 2, 3, and I want to have all the permutations of it, all the permutations. So what I can say is, okay, listen, I'm going to have the string and I know the next permutation is 1, 3, 2. I know the next permutation, like if I talk about dictionary order, 2, 1, 3. The next permutation is 2, 3, 1. The next is 3, 1, 2. The next is 3, 2, 1. Can I say these are the dictionary, like these are the 6 permutations that you can have. 3 factorial is 6. So if you want to print them, what you do is you first print the first string. Then you say, can you have the next permutation, please? Can you have the next permutation? And it takes you the string which was this becomes 132. And now you print it. Again, the string now becomes 213 and you print it. Again, the string becomes 231, you print it. Again, the string becomes 312 and you print it. Again, the string becomes 321 and you print it. Right after this, it goes to null. It says no more permutations. It returns a false. If there are no more permutation, it returns a false. And if it returns a false, the while loop breaks. And this is how you can print all permutations of a string. Here's a catch. What if the string was 231? Then it would have started from 231 and the next permutation of 231 is 312 and the next is 321. So it would have just printed like first this, then this, right after this, no permutations. So it's very important that if you want to print all the permutations, you start from the sorted guy. Like you just start from the sorted guy and you can easily sort it. You know the STL now. In this fashion, you start from the sorted guy and that's how you can easily print it. Now the last one is max element. Imagine you have an array like 1, 10, 5, 6 and you want the maximum element. So if you give max element start iterator, end iterator, it gives you the address, and if you give the star, it gives you the element. Similarly, min element is also there, right? So these are the algorithms that are generically used in DS algo in your day-to-day life. All the other algorithms are there, but they are not widely used and you will not be requiring them. So whatever STL I've taught in this video is more than enough to get started with C++. So just in case you've understood everything, it's an earnest request that get into the comment section and just write one line comment, because that is the only thing that